So yesterday we have seen, in the last class we have seen what is VPC and how the VPC works in AWS. So then we have created a VPC, okay, in a region, and we have created public and private subnets. Okay, and inside we have created a public and private subnets, and then we have created an internet gateway, and we have attached this internet gateway to our VPC. Okay, so today we are going to see some more other concepts. We will go with the same architecture and we will add some more to this architecture. Okay, now we will create a EC2 instance in a public subnet, and let's see like how the internet flows into this EC2 instance. Okay, so I'll open my AWS console. Okay, now we are in our AWS console. Let's go to VPC. So click on VPC, and then we'll go to, first we'll see one by one, like we have created our subnet. So we'll select our VPC here. So this is the one which we have created, the demo VPC. So we have one VPC. We have created 4 subnets, 2 in a private and 2 public subnets, and we have an internet gateway. So we have created an internet gateway, and we attach this internet gateway to our my demo VPC. Okay, so and one more thing we have done. So we have created public subnets here. So and we have set this auto assign public IP to yes. So whenever we create a instance in a public subnet, so it will automatically get a public IP. Okay, so and for the private subnets, there won't be, we are not enabling this option because like private subnets are not internet based, so they are not connected through internet, so we won't allow any internet access to the private subnets. So we won't give any public IPs for the instances which are in a private subnet. Okay, so till this like we have created. So now what we'll do, we'll create an instance in a public subnet, and let's see like how we'll connect to this. Okay, so we'll go to another tab. We'll go to EC2, and we'll create an instance here. So we have no instance running now. So we launch an instance, and we call it my public EC2 instance. Okay, so we are keeping all the same. We are going to a free tier eligible T2 micro instance, and we'll select this my demo VPC key pair, and here in the networking we'll edit it, and we'll create this EC2 instance in the VPC which have created. So I'll create this in my demo VPC, and we'll select this, we'll create the instance in this public subnet A. So I'm selecting the subnet. So whenever you select this, see here the auto assign of public IP will be enabled because in the subnet settings we have enabled this option. Okay, so I'll create a new security group, my EC2 demo EC2 instance SG security group. Okay, so that's fine. We can leave all this like this, and we'll create a launch an instance. Okay, we'll go to our instances. So here we got our instance. So if you click this, see here we got a public IP. As we have created our instance in a public subnet, and auto assign public IP option is enabled, so AWS will automatically assign a public IP to this instance. And if you can see here, that VPC is my demo VPC. The subnet is public subnet. And here we'll get a IP address from the CIDR range of this public subnet. So here we have given a CIDR range of 10 to/24. So that means this last two will be only this last one will be changed, right? So every IP which we create in this public subnet will start with 10.0.0 and we'll get from 0 to 255 IPs. So here when we create an instance in this public subnet, we got an IP like 73. So this is common for this subnet, and here the IP number will be changed. The fourth octet will be changed. So now we have EC2 instance. We got a public IP. So let's try to connect to this. So I'll go to connect, instance connect, and I'll try to connect to it. So if you see here, so it got connected. Okay, but like 1 second. So if you go to our subnets and if you go to the routing table, so I see here I have done a configuration here. So in the public subnets, like if you try this, like you may get like some errors here. So to solve this, to make this connected to internet, what we'll do is, so we have created a instance in this public subnet. So we'll go to this public subnets. Okay. And if you click on this, so if you go to the root tables here, edit the root tables. So here we have the route tables. So by default, like we won't get this option here. So I'm removing this. So by default, we won't get an option. So we'll get something like this when you create a default route. Okay. So if you can see, so what are the subnets associated? We have a route table here. This is the default route table for the VPC. So when you select this, you can see the subnets associated to it. So what are the subnets you have created in this VPC? Those will be explicitly connected to this public subnets. So that means like we have not associated our subnets to this, but they are explicitly associated because there is no other route tables. Okay, so this will be something like this when you try to create. So you close this, and if you try to connect it again, see now. So initially, like when you have created a subnet and you create a instance in it, so initially you will get like this because like we have not allowed any internet connection to our public subnet. So what we'll do is we'll create a route tables and we will, so we'll do something like this. So here what we'll do is we have an internet gateway already and we have an EC2 instance, but like to access this internet from to this EC2 instance, what we'll do is we'll create a router here and we'll define some routes like to which route we need to allow this internet to our EC2 instance. Okay, so we'll go to our AWS console again. Okay, we'll go to our VPC and here in the route tables we'll create two other routes. So we'll be working on my demo VPC. So here we'll create two routes. So first one is so public routes, and we are creating these routes in my demo VPC, and here we will create this route table, and again I'll create another route table. So this is private routes. So this is also we are creating in the same VPC. So here now we have two route tables. So now what we'll do is we'll assign the subnets to this particular routes. So to do that, we'll select this. If we go to actions and edit subnet associations. So here this is the public route. So I'm selecting my two public subnets and associating them to my public routes. So here we have added two. Similarly, we'll do for this, and we'll add the two private subnets here. So we'll add these two private subnets. Okay. So now we have two routes. One is public and other one is private. So in the public route, we have two public subnets, and the private route, we have two private subnets. So when you click on this default VPC, now see, so there won't be any subnet because they are associated to this particular custom. We have made some routes. We have created custom routes and we have associated them. So they are associated to this respective routes. So now if you see what we have done is, so now we have created a router and we need to define the route tables to access the security group. Okay, so to this instance. So if you go here and if you try to connect it again, so I'm going to my EC2 instance, and if I try to connect it again, see again, it's still showing some errors. That means, so we have defined a EC2 instance and we have created the EC2 instance in the public subnet, and we have added a router and we have added some public subnets into this public router. So, but one thing is we need to allow this public router to access the internet. So when we go to this routes here, so when you click on this public routes and you select here like the routes, here we have something like this. So go and click on edit. So here what it is saying is, so whenever a traffic enters into this route table with these IPs, that means so IPs from 10.0.1.0.0 to 10.0.255.255, whenever a traffic enters into this particular subnet, okay, of the router with these IPs, then target is local. So that means redirect them to the local VPC. So whenever we use any IPs with this range, so it will try to communicate with the servers which is in the local, that is in the AWS VPC. So what about the other IP? So when you are trying to hit this server or trying to connect to this EC2 instance, connect through internet, so there will be different IPs. So for example, my public IP address. So this is, so here IP address. So if you see, so this is my public IPv4 address. So this is the address which is trying to connect to this EC2 instance, okay, through this route. So but we have not defined any routes for the other IPs other than this. Okay, so now what we'll do is we'll add another route and we'll say, so if we get any other traffic from outside, so other than this, so if you get any out of this traffic, so target is local. So that means you check the, you you redirect to the servers which are in the local. So other than this, if you get any other IPs, then we need to, so we have different endpoints. So then we need to transfer it to some internet gateway, and the internet gateway is something which we have created here. So we'll save the changes. So now what happens is, So we have an EC2 instance or public subnet, right? So in this public subnet, we have a routes table. So now this routes table also got this internet gateway. So any other IPs which are coming from the internet, so the target is internet gateway. Okay. So now we'll go again here to our EC2 instance. We'll try to connect it now. So see, now we are able to connect to internet, right? So if you do something like ping google.com, see here like we are getting the response from the google.com. So that is like we are able to connect to EC2 instance to internet. Okay, so this is how it works, the internet gateway. So now we have created internet gateway and we have created a public router, and in that router we have defined an IP address here. IP address header range, like so if there is 10 10.0.0.0/16, if that pool of IPs comes here, then it will like communicate to the local or any other IPs that comes into this, okay, EC2 public subnet. So then it will connect to the internet. So this is how we provide this internet gateway to our VPC. Okay. So coming to the other thing, so there's something called a Bastion host. Okay. So we can use a Bastion host to SSH into our private EC2 instance. We know like when we create a instance in a public subnet, we are getting a public IP. So through which like we are able to connect to the public EC2 instance in the public subnet using that public IP. But when you create an EC2 instance in a private IP, there won't be any public IPs because like that was closed and that was inside VPC, and we are not able to connect to private subnet or the instances in the private subnet, okay, directly from the internet. But if you want to connect to the private subnets, but like we need to use the servers, right? So to use that servers in the private subnet, we need to, okay, log in into the servers. To do that, like we will use this Bastion host. So some people will call it a Bastion host, like some terminologies they will call it as jump box or jump server also. Okay. So the Bastion is in the public subnet, which is then connected to all other private subnets. That means like this is our, okay. So this is our public subnet, and inside this public subnet we'll create an EC2 instance Bastion host. Okay, and this Bastion host will be, okay, available and can be connected through internet, and from this Bastion host we are able to connect it to all other, okay, instances in the private subnet, because like this public and the private subnets both are in the same VPC. They can be connected internally through private IPs. Okay, so the users will SSH into the public subnet to EC2 Bastion instance through public IP, and when they enter into this Bastion, okay, host EC2 instance, from here it can use to connect to private subnet EC2 instance with private IP. Okay, so Bastion host security group must allow inbound from the internet on port 22. As I said, like this Bastion host need to allow the SSH traffic from internet. Okay, for example, the public CDR of your corporation. So we won't allow all the traffic to this Bastion host. Like we will allow only some few IPs. Like if there is like few set of IP ranges for your company or a corporate sector, we will allow only those IPs from inside, from the internet to our Bastion host. So that means say like my company has a private IP of some like 10.250 or like 192 something the IP. So that was a static IP and that won't change from our corporation or my company. So what I'll do is like I'll allow only that IP. Okay, I'll allow only that IP to the Bastion host, and from this Bastion host we'll connect to other private subnets. Security group of the EC2 instance, okay, must allow the security group of Bastion host or private IP of Bastion host. So if you want to connect from this Bastion host to these private subnets, either you need to allow the traffic of this private IP to this public subnets. Okay, so whenever you create this EC2 instance, there will be a security group, right? So in this security group, either you need to allow the private IP of this Bastion host, or the security group of this Bastion host. So if you allow any of these two, you will be able to connect to this private subnet from your Bastion host. Okay, so we'll see how this works. So again, we'll go to our EC2 instance. So EC2 here, we'll close this. So this is our instance. So I'll make this as my Bastion instance, because as this is created in a public subnet, so we can use this as a Bastion instance. So now to connect, like I'll create a other instance in a private subnet. So my private instance. So I'll create a private instance here, and I'll keep all this same. I'll use the same key pair for this. Okay, and here in the network settings, so now we are creating in our demo VPC, and we are creating a private instance in a private subnet. So we'll use this private subnet A. So if you see here, the public IP assignment is disabled. Okay, so I'll create a new security group, my private EC2 security group. Okay, so I'll allow SSH from all the IPs as now. Or else what we can do is, we won't allow all the SSH traffic into it. Other than that, what we'll do is, we'll do a custom thing, and we'll select my demo EC2 instance. So this is my security group of my Bastion host. Okay, so I'll allow this security group. That means like I'll now be able to connect to this particular SSH, okay, particular instance from my public Bastion host. Okay, so this is security group of Bastion host. Okay, so now we are creating this, and we'll launch this instance. So we'll go to instances here, and this is my private instance. Okay, so here if you see, there is no public IP address because this is in a private subnet. Okay, and we have a IP here. So here the IP range started from 17 to, we got 1713, because here we have given the public subnet TS header as 20 here, /16/20. Okay, so that's why we got this range here. So now our private instance is connected. So if you try to connect to this instance, see, the instance does not have a public IP address, so we cannot connect it through internet. So okay, so we won't get, at least we won't get this option also. So now what we'll do is, to connect to this EC2 private instance, first we need to enter into my Bastion host, right? First we need to enter into our Bastion host, then from the Bastion host we'll connect to this private instance. Okay, so I'll go here and I'll connect to this instance here first. Okay, so now we are in our Bastion host, that is 10.0.0.73. So if you go here and see, this is the IP of that. So 10.17.113. So this is my Bastion host instance. Now from this, this is my Bastion host instance, 10.0.0.73. From this, we need to connect to our private instance. So for that, what we'll do is, first we'll see what is the key pair that is being used by this private instance. So if you go here, so this is it is using my demo VPC key pair. So I'll import this key into this instance first. To do that, like first what we'll do is, so first we need to copy that key. Okay, so we'll go and copy that key first. And we'll put it in some editor. So we'll say my demo VPC dot em. VI is an editor, so something like a notepad in Windows. Okay, so when you say VI space some file name, it will open a file, okay, with this name which you have given, and you can write any text in that file. Okay, so now I'll check my key dot pm. So what is the key name here? My demo VPC key. So you can open that key with some notepad or something which you have created. So here we have that key. So I'll open it with some editor. Okay, so when you open that key, so you'll get something like this. You'll get something like this. We'll copy this, the key content. Okay, and we'll go to our EC2 instance, and here you can paste it, and then you click on escape colon WQ. So escape, then colon and WQ. So this will save this file with the content. So if you see this cat my demo vpc.pm, so you got your key here now. So using this key and this private IP, so we have our key and we have a private IP here. So using this two, we'll try to connect to our private instance from our Bastion host. So we'll go here and we'll say SSH EC2 user at the rate this IP. Okay, so we need to provide the key. So we say -I. Again, we'll see my demo vpc.pem. So it will ask something like this. Click on yes. So we are getting permission denied. So we need to give the permission for this key file. So for that we do chmod 0400 my demo vpc.pem. So then we'll try it again. So we'll try to connect to the EC2 instance. So now if you see, so now we have, so this is our public, okay, instance, the Bastion host instance. So here we have connected to 10.0.17.130. So that now we connected from our Bastion host to our private IP. See, so we are in a private IP, and now this private IP will not have any internet access. So if you try ping google.com, see, it's unable to do a ping. So because there is no internet access connected to this private EC2 instance in our private subnet, but still we are able to connect to it using our Bastion host, which is in a public subnet. Okay, so this is how like we enter into our private EC2 instances which are in a private subnet from our public subnet instances. Okay, so sometimes this is called as a jump server also. So only this jump server or the Bastion host will be like faced to the internet, and all other instances will be in a private subnets. So like this, now we have done an SSH into our Bastion host, and from there we have SSH into our private subnet. Okay, so this is how we use this Bastion host or jump servers. And coming to the next thing, we have something called a NAT instance. Okay, but this NAT instance is something which is outdated, and from 2022, 2020, they have been not using this NAT instance. So instead of this, they are using NAT Gateway, but like we still need to know about this for the exam. So what is NAT? So NAT is something called as Network Address Translator. So it allows EC2 instance in a private subnet to connect to the internet. So as we have seen that, so the instances which are in the private subnet, so they are not able to connect to internet. Okay, so because like in the public subnet we have created a route table, and then in that route we have redirected all the public IPs to some internet gateway directly. So all the instances which are in the private subnet will get an internet access. But for the public subnets, like we are not facing them to the internet and we have not given any routes, okay, so which enters through internet. So this private subnet, so instances which created in this private subnet will not have internet access. But through this NAT instance, okay, we can provide internet access to the okay EC2 instances which are created in the private subnet. Okay, this NAT instance must be launched in the public subnet. Okay, so the instance which is used as a NAT instance that must be created in a okay public subnet must disable EC2 settings source and destinations checks. So in EC2 instance network settings we have something option called source and destination checks. So that must be disabled for this NAT instance. Okay, and you must have an elastic IP attached to it. For every NAT instance we must have an elastic IP. That means that IP, the public IP, must not change for this NAT instance. Okay, and the route table must be configured to route the traffic from private segment to NAT instance. So the route tables here must be configured to the route traffic from private subnet to NAT instance. Okay, so the private route table subnet must be changed and it need to allow the traffic from the NAT instance. Okay, so we'll try to create this NAT instance. This is not like much needed for the hands-on section, but still we'll try to do this. So to do this, what we'll do, we'll go to our EC2 instance session here. So we'll go to this launch instance. So now we have this private instance here. We'll use the same private instance. Okay. And we'll try to create here. So this NAT instance, like we have by default get some NAT instance from this AMIs, Amazon AMIs. So we'll click on this Amazon AMIs, and if you search for NAT instance here and click on enter, so you'll get some community AMIs like this. So these are like predefined NAT instance that we get from like AWS community, and here there are a lot of things NAT instances, and based on this date, published date, I think we can check and take any other NAT instances. Okay, and here we have an Amazon Linux NAT instance, and this is of architecture 8664. This will be fine, and this is published on, this is the latest publish, so we can go with this also and select this. We'll say this as NAT instance. Okay, we'll keep this as same, so T2 micro. So we'll use the same key pair here for the NAT instance also. So we'll create a new security group. So we'll go edit, and we'll create this in our my demo VPC. And as I said, this NAT instance must be in a public subnet. So we'll create our we create it in our public subnet. Okay, and so it will get an organization public IP, and here we'll get this firewall settings, and we'll say this as NAT security group. Okay, that's fine. So we need to add some more here. We need to allow some traffic to this. So that means including with this SSH, we'll add some more rules. So we'll add this HTTP traffic. So the custom range is, so we'll allow this from 10.0.0.16 0/16. So this is like, because we allow only the traffic, HTTP traffic from this VPC, all the servers in the VPC. So similarly, we'll also add this HTTPS. So 10.0.0.0/16. So we'll allow all the HTTP and HTTPS traffic from all these private instances or all the instances which are created inside the VPC, and everything is fine. Okay, we'll launch this instance now. So now we have got a NAT instance here. So first thing you need to do is like right click on this and go to networking, and here we have change source and destination checks. So as we have already discussed, we need to stop this. Okay, so save this. So now we have this NAT instance here. Okay, so now we'll go to our routes again. So now we have an NAT instance and we have a private instance. Okay, an instance in our private subnet. So now we'll go to our subnets, and now we'll select our VPC. So now we have a private subnet here. So we have a private subnet where we have created our private private instance. So we'll go to the route tables here. So here in the route tables, we'll edit this route table and say, we'll go to the routes and routes. So these are our private routes, private router, and we'll go to the routes here. Here, if you see, these are the subnets associated to this, the private subnets. We'll go to the routes. So it is not allowing any other traffic other than this IPs in the private. So here we'll go to this edit routes and we'll add, and here we'll say, so if we get any other IPs other than this, we'll forward it to our NAT instance. So we'll select this instance and we'll select this NAT instance. Okay, so that means when you try to give any traffic from the other IPs, then it will pass through NAT instance. So we'll save this. Okay, so now again, so now we are in our we need to allow one more thing. So now again we'll connect to this. So here we are in our public instance now, Bastion host now, because like to connect to our private instance, first we need to get into our Bastion host, and then we need to connect to our private IP address. So this is our private IP. So now we are in our private instance in a private subnet. So I'll clear all this. So now we are in this private subnet. So to do this, we need to, for the ping, we need to allow a IP, allow a port. So see here the ping is not working, right? So that means like we have allowed the NAT instance, but it is not getting any response because we need to do one more thing. We need to go to the private subnet security groups, and here we need to allow, not here, like we need to go to our EC2 instance, and in the NAT instance we need to allow one more thing. So we need to add an inbound rule for the ping. So this is called ICMP, custom ICMP, all ICMP i4, and we'll save these rules. So we'll allow from all IPv4, we'll save these rules. And now if you try to ping, see, now we are able to access internet to our private instance. Okay, so this is how we use our NAT instance. Okay, so what we have done is, so here we have created a NAT instance and we have routed that to our private subnet. So whenever you get, so if you can see this diagram, so say like this is the server which is trying to put a request to our private IP, so which we want to connect to private IP. So what happens is when this particular private IP wants to connect to internet, so it will go through, so say like it is, So when I click on ping google.com, this google.com has some other IP other than this private IPs, right? So say like the google.com IP address is 40.1.2.3. So when we got an IP address something like other than this, okay. So here we have defined this route tables, right? For the private subnet. See, for the private subnet, we have defined these two routes. So if you get any IPs, okay, so if you try to connect to any IPs which start with 10.0.0./16 pool, it will go directly to that EC2 instances, okay, because these all are in the same subnet. But when you try to go with any other IPs other than this pool, so what happens? It go to the, okay, NAT instance. That means like the request will go from the private IP to the NAT instance. So here the source will be this IP address and the destination will be our NAT instance. Okay, the destination will be the server which you are trying to connect. So when it enters into the NAT instance, it will connect to the same source, but it will connect through the IP which is of the NAT instance. Here the NAT instance IP is 12.34.56.78. So the request goes to the server from the NAT instance. That means the source will be this IP and the destination will be the server IP. Okay. Similarly, when you get a request, when you get a response from this server, so the source will be from this server and the destination, the response will be sent to this NAT instance. So it will not send directly to the private instance. The response will be sent to the NAT instance. And from this NAT instance, here the source is still the same server response and the destination will be changed to this private IP from this NAT instance. So this is something like it is translating the IP address. So it is not giving the original IP address of this private instance. It is translating the IP and sending to the server. So that's why it is called as network address translations. Okay. So this NAT instance will translate the IP address and it will send to the server which is outside in the internet and it will receive the response from the server and it translate again here and it is sent to this particular IP, private IP, so which has sent that request. Okay, so this is how we use this NAT instance to connect to internet for this private subnet EC2 instances. Okay, so this private subnet is not directly connected to any other internet gateway. So it is connected to this NAT instance and then it is connected to this internet through NAT instance. Okay, like this is being used in the past. So now instead of using this NAT instance, AWS has got something like a NAT gateway. So what is this NAT gateway? It is fully managed by the AWS and it has a higher bandwidth, high availability, and we no need to do any administration or any customization for this NAT gateway. So it will be automatically high available and higher bandwidth. So we'll pay per hour for usage and bandwidth. So when we use this NAT gateway, we'll automatically like pay for hour, like how much time we are using and how much bandwidth we are using, we'll pay for that NAT gateway. So NAT gateway is created in a specific availability zone and uses an elastic IP. Okay, so whenever you use a NAT gateway, so you need to create it in the same availability zone. Okay, so can't be used by EC2 instance in the same subnet. So when you have an EC2 instance in the public subnet, say like you have an EC2 instance in this subnet, here in the subnet, here in the same subnet, you cannot create the NAT instance. So we need to create an EC2 this NAT instance in a different subnet. Okay. So another thing is it requires an internet gateway. So and the flow is something like this. It will go from private subnet to NAT gateway, and this NAT gateway is connected to internet gateway. And the speed is like 5 GB of bandwidth, 5 Gbps of bandwidth with automatic scaling up to 45 Gbps. You don't need to do anything for this. It will automatically scale based on the load or based on the usage or based on the bandwidth you require. It will automatically scale to 45 Gbps. And we no need to define any security groups to manage it. So AWS will take care of this. Okay. So now we'll see how this works. So here we have a VPC. Inside VPC, we have this public and private subnets. Okay. Inside the public subnet, we have some public instances, and we have a NAT gateway here. Okay, so till here we have created. So what this NAT gateway do is, so if you want to create to connect to any other instances in our private subnet, so we need to connect it to through NAT gateway. So as we have already seen, this NAT gateway must not be in the same subnet. So we'll create this NAT gateway in the public subnet. Okay, so from the public subnet, we'll create a router to connect to this private instance, and this NAT gateways will be connected to internet gateway. So this is how the internet flows to the private subnet using the NAT gateway. Okay, so we'll try to do a hands-on on this. So we'll go here, and now, so we have an internet gateway here, and we'll go to our NAT gateway. So here we'll create a NAT gateway, and we'll give my demo NAT gateway. Okay, so we'll select a subnet here. So we need to do it in a public subnet. So we're creating in a public subnet A here. Okay, so we need to get an, if you have an elastic IP, you can select an elastic IP. So as of now, we don't have any elastic IP. So we'll say allocate an elastic IP. So this will create an elastic IP and allocate to this particular internet gateway. So now everything is fine. So just create this NAT gateway. And now we have this NAT gateway created. Okay, so we have our NAT gateway here. It's saying it's pending. It'll take little time, I think. So meanwhile, what we'll do is we'll try to attach this NAT gateway in the route tables, because like we need to, here we have now created a NAT gateway, and we need to route this particular NAT gateway. We need to change this route tables, and we need to, okay, we need to give an access to this particular NAT gateway from this private subnet using these routes. Okay, so now if you go to our routes table, okay, we need to give the access to the instances which are in the private subnet, right? So we'll go to our private router, and in the routes, so we'll edit this routes. So now what we'll do is, instead of going with this, so this is our NAT instance. So instead of going with this NAT instance, we'll go with internet NAT gateway. Okay, so we'll do NAT gateway, and this is our NAT gateway which we have created. So we'll select this, and we'll save the changes here. Okay, so now we have a NAT gateway. The state is still pending. So we have a NAT gateway, and we have attached this. So this is available here, and we have attached this NAT gateway to our private router. So we'll go again. So we'll do from the beginning. So we'll go to our instances, and from this instance, we'll try to connect to. First, we need to connect to our Bastion host. So this is our Bastion host. So connect to this Bastion host. Okay, from here, we need to connect to our private IP. So private instance. So this is my private instance. I'll copy this IP address. And here we have our key. And we'll SSH pc2-user at this private instance, and we will use this key pair, my demo VPC key pair. So now we are in our private EC2 instance. So clear this, and now we'll try to ping google.com. So see, again now we are able to connect to internet. Okay, so if you say curl some example.com, so curl, so we'll get something response like this from the internet. Okay, so this is how we are connecting. So we are connected to the internet from this private instance, but now this is not from the NAT instance. So but now like we are using NAT gateway. Okay, So now we have created this NAT gateway and we have routed this all the traffic other IPs in the route table to NAT gateway, and this NAT gateway is connected to this internet gateway, and through this internet gateway it is able to connect to this instance. So why we are using this internet to this private subnets? So as we have created this private subnet saying that it won't be faced to internet. And again, why we are like trying to connect to internet means like when you are creating an instance in a private subnet for initial setups, like to install some softwares or to install some OS patches or to do some settings, like you need to get some internet access to the subnet initially to do some changes. Or else like when you have any maintenance work which you need to do in the servers which is in the private subnet, you need to get an internet access to this. So at that time, you just connect a NAT gateway and you provide internet access to your private instance, private subnet instance. And when your work is done, you can remove this route table, remove this IP or the network gateway from the route table, and then there won't be any traffic entering into your private subnet through internet. Okay, so this is how they use these NAT gateways and NAT instances to provide internet access to your instances which are created in a public subnet and which are not internet based. Okay, so this is something about NAT gateway and NAT instance. So we'll see, we'll almost at the end of the session. So we'll see what are the, there is other thing called NAT gateway with high availability. So we are using one NAT gateway, right? So when we are using different subnets, okay, so then we can be able to create multiple NAT gateways to provide high availability for your environment. So NAT gateway is resilient within single availability zone. Okay, so in a single availability zone, you can create a single NAT gateway. So if you want to create multiple NAT gateways in multiple AZ for fault tolerance. So when you are using multiple availability zones, say like here we have two availability zones, but like in the previous example, we are doing out all in one availability zone. Okay, so but when we learned about this high availability in EC2 instance about auto scaling and all, so what happened is we'll create different availability zones, and we'll keep all these EC2 instances in different availability zones to provide high availability, because like whenever there is a disaster in your first availability zone, so that the second availability zone will be like serving all your requests, so that at the time like there won't be any downtime for your applications. So whenever you are using multiple availability zones, then you need to create another gateway in each availability zone. So this will give you a fault tolerant and will give a high available architecture, like high available environment to run your applications. There is no cross AAC failover needed, because if AAC goes down, it does not support NAT. So whenever this AC is down, so automatically this NAT gateway will get down. So there won't be any traffic entering into this particular NAT gateway and the instances. Okay, so whenever you need to create a NAT gateway for each availability zone when you are creating some multi-availability zone architecture. Okay, for each availability zone, you need to create a NAT gateway. Okay, and one more thing. So, what is the difference between NAT gateway and NAT instance? We'll see. So, coming to the availability, so NAT gateway is high available within availability zones. So, a NAT instance is like you need to use some scripts, manual scripts to capture this failover between the instances. Okay, but NAT gateway has an option to go with multiple availability zones, and it will give for high availability. And coming to the bandwidth, so the bandwidth of NAT gateway is up to 45 Gbps. And in the NAT instance, it depends on the instance which you create. So we have different types of instances, different types of configurations, right? So based on the instance which you select, so it depends on the instance which you select. Okay. So the maintenance it is fully maintained by AWS, and this NAT instance is managed by our own, because like this is something which we have created just like an instance. We need to do all the software patches and all, so we need to maintain this. So the cost is, it is NAT gateway's cost, like it will be costed per hour, it will be charged per hour, and the amount of data transferred through the network gateway. Okay, NAT gateway. So for the NAT instance, it will also charge per hour for the instance. So for the EC2 instance which you have selected, based on the EC2 instance which you have selected for NAT instance, that instance cost per hour plus the network bandwidth cost will be charged for this NAT instance. And it supports both IPv4 and it supports both private IPv4. So this is same for the both. And when you come to the security groups, you don't need to create any security groups and allow it. So you just create it and AWS will manage about the security groups. And here, but in the NAT instance, we need to create a security instance and we need to allow that security group to the private subnets. And here, this can be used as Bastion host, no. But this NAT instance, as we are creating this NAT instance in the public subnet, this can be used as a Bastion host because this is a EC2 instance and it is created in a public subnet. We can use this as a Bastion host, but this NAT gateway cannot be used as a Bastion host. Okay, so that's it for today. Like we have seen what is NAT gateway and what is NAT instance, and we are also seen how to create a private EC2 instance in a private subnet and how we'll connect to private EC2 instance using Bastion hosts. Okay, so this VPC is something like we need to have much more idea on networking. Like basic idea is enough. Okay, so you need to go thoroughly. You need to read some documents regarding all these concepts. Okay, so today, like we have seen three concepts. One is Bastion host, internet, NAT instance, and NAT gateway. So try to read some white papers regarding this particular three concepts. So not only this, like every day, what are topics we are covering, try to go with all these topics, and like you will be able to like gain much more knowledge on these each topics. Okay, fine. We'll meet in the next class. If you have any doubts, like you can ask.